Welcome. Today we're going to pull back the curtain on one of the most powerful skills you can learn, programming. Seriously, think of it as learning a new language, one that lets you have a super specific, super powerful conversation with a computer. Ready to see how it all works? Let's get into it.
Think about it for a second. That game you can't put down, the social media app you're always scrolling through, it all started as just an idea in someone's head. The magic that turns that spark of an idea into something real that you can actually use, well, that's programming. And you know what? It's not nearly as complicated as you might think.
So why can't we just, tell our computer, hey, build me an awesome new app? Well, it all comes down to this massive communication gap. We can talk in one way, and computers, they're on a completely different planet. This slide really nails the difference. On one side, you've got us, with our messy, creative, natural languages. And on the other side, you've got the computer, which only gets one thing, electricity, on or off. That's it. We represent that with binary, just zeros and ones. Programming languages were literally invented to be the translator, the bridge that connects our world to theirs.
Okay, so when we use one of these fancy programming languages, what are we actually making? We're building a program. And honestly, the best way to think about a program is to imagine it's a recipe. A very, very precise recipe that you give to the computer.
Let's take a simple problem, like finding the average of a bunch of numbers. Now, if you have 10 different sets of numbers, doing it by hand with a calculator is a total drag. It's repetitive, it's slow, and you're probably going to make a mistake. A coder looks at that and thinks, no way. The coder's way is to write the procedure, the recipe, just one time. Then you hand it off to the computer and bam, it does all that repetitive work for you, instantly, perfectly, every single time. That's the power of a program.
And that brings us to the core definition, right here. A program is nothing more than a set of instructions. It's that procedure we just talked about, written in a language the computer gets, telling it exactly what to do, step by step, to finish a task.
So, we know what a program is. Now let's look at the actual nuts and bolts. Let's talk about the basic building blocks of any programming language, kind of like the vocabulary and grammar that let us write those instructions.
Let's break down this little line of code. It might look really simple, but it is packed with information for the computer. First, we're saying int, which tells the computer we're dealing with an integer, a whole number. Then we have a, which is what we're naming our little piece of data. And finally, we're saying it's equal to 10. So we're storing the number 10 in a spot named a.
That letter A we just saw, that's what we call a variable. And this is one of the most crucial ideas in all of programming. The best analogy is to just think of it like a labeled box. You give the box a name, that's your variable name, and you can put information inside it. Later on, you can just use that label to see what's in the box, or even swap it out for something new.
So how in the world does the computer know what int a equals 10 means? Well, it knows because of syntax. Syntax is just a fancy word for the grammar of a programming language. Just like English has rules about where your verbs and nouns go, programming languages have super strict rules about where to put keywords, variables, and all those symbols. If you get the syntax right, the computer understands you perfectly. If you get it wrong, it has no idea what you're trying to say.
Remember the int we saw? That's a data type. Its job is to tell the computer what kind of data to expect in our variable box. Is it going to be a whole number, like an int, or maybe a number with a decimal point, like a float? It could even be a single letter, which is a char, or a simple true or false value, which we call a Boolean. Telling the computer the data type up front helps it manage its memory and work way more efficiently.
Okay, so we've got our instructions and our variables, but a program isn't just a random list of commands. We need to be able to control the order, or the flow, of how those instructions get executed. This is where the real logic and decision-making comes into play.
First up is the most basic flow, sequential. It's exactly what it sounds like. The computer reads your code line by line from top to bottom and executes each one in order. Step 1, then Step 2, then Step 3. Super simple.
But what happens when you need your program to make a choice? That's where selection comes in. This is your classic if this, then that logic. The program checks if a condition is true. If it is, it runs one piece of code. If it's false, it might run a totally different piece of code, or maybe do nothing at all. This is how apps are able to respond differently depending on what you do. And finally, we have iteration, or what pretty much everyone calls loops. This is the programmer's secret weapon for handling repetitive tasks. Remember our averaging problem from earlier? A loop is how you solve that. You just tell the computer, hey, repeat these instructions over and over until this condition is met. This is really the key to making computers do all the heavy lifting for us.
Now here's a really important point. Before you write a single line of code, before you even think about variables or loops, you need a plan. In the world of programming, that plan is called an algorithm. Think of it as the blueprint for your entire program.
An algorithm is purely about the logic. It's the step-by-step procedure for solving your problem, written out in a way that a human can understand. It's all about figuring out how you're going to solve the problem long before you start worrying about the specific syntax of any language.
This slide shows the difference perfectly. On the left, you have the plan, the algorithm. We often write this in something called pseudocode, which is basically just an informal plain English description of the steps. On the right, you have the actual code. That's the execution of your plan translated into a specific language with all of its strict grammatical rules. You always start with the plan.
So, we've covered the what and the how of programming. But let's talk about the why. Why should you even consider learning this skill? Well, because it opens up a whole new world of creativity and incredible opportunities.
And if you're feeling ready to get started, here are some of the most popular and beginner-friendly languages out there right now. Languages like Python and JavaScript are amazing for beginners. Things like Swift and Kotlin are must-haves if you want to build mobile apps. The key is you don't need to learn them all. Just pick one that seems interesting and dive in.
You know, the benefits go way beyond just building cool stuff. Learning to code actually changes the way you think. It teaches you to be a more structured, logical thinker. It forces you to take these huge, complex problems and break them down into smaller, solvable pieces. And yeah, of course, it's also an unbelievably valuable skill in today's job market.
I love this quote because it really captures the feeling. It's about empowerment. It's about having the ability to see a problem or dream up an idea and then actually having the tools to build a real tangible solution that can help people. It's an incredible feeling.
So, there you have it. We've walked through the fundamentals, from that gap between us and computers all the way to the logic of algorithms. You now have the basic concepts down. So the only question left is, what problem are you going to solve first? What idea are you going to bring to life?